Mm, Bismillahirrahmanirrahim. Dear students, today we are going to discuss the fuel cell measurement. First of all, we have to know what are the fuel cell. Fuel cell, basically, fuel cell is a device. Uh, a fuel cell is a device which converts the chemical energy of a fuel into electrical energy. It has three components. The first one is anode, second is cathode, and third one is electrolyte. Now at anode, what happened at anode? You know very well that at anode the oxidation of a fuel will take place, while at cathode usually the reduction process will take place, reduction of air or something other. And electrolyte, what happened with electrolyte? At electrolyte, the movement, the migration, or the movement of the ions would take place. There are different types of fuel cell which are working around us, like polymer electrolyte, membrane fuel cell, alkaline fuel cell, phosphoric acid fuel cell, alcohol fuel cell, and solid oxide fuel cell. So usually now in today's topic we are going to discuss the solid oxide fuel cell. Solid oxide fuel cell is a type of fuel cell which is in which all the material which are being used, like anode, cathode, and electrolyte, they are in the solid form. Okay, in solid oxide fuel cells, uh, all the material which is being used is in the solid form. So today we see that how can we measure the performance of a solid oxide fuel cell. Here Just like a simple fuel cell, it has also three components: anode, cathode, and electrolyte. And electrolyte is a sandwich between the anode and cathode. No, towards anode, hydrogen is being supplied. Hydrogen is used as a fuel. Hydrogen is supplied toward anode side, while at cathode air is supplied. And electrolyte is in between, or you can say that sandwich between, or sandwich or in between, our sandwich among anode and cathode. So this the fuel the solid side fuel cell palette, which is just like a button. Here we can see the SOFC, or solid side fuel cell. The solid side fuel cell is abbreviated as SOFC, solid oxide fuel cell. Is just like a button having these three components. Here you can see that what are the three components and how they are. Here at upper side there is a layer of cathode, while the electrolyte is sandwiched between these two electrodes, and beneath of these two layers, the third layer belongs to the anode. So such type of palette is formed, which is like a button shape or button like shape. So uh, this is whole configuration of solid oxide fuel cell, which has all the three components in it. Okay, so here we can see that fuel cell testing was performed by supplying the pure hydrogen as a fuel to the anode side. Mean we supply hydrogen towards the anode side while air towards the cathode side of the pellet. Okay, the result was calculated in the temperature range of, as solid oxide fuel cell work at high temperature, about 400 to 1000 degrees centigrade. So our this material is working is 450 to 650 degrees centigrade with the interval of 50 degrees centigrade, using fuel cell measurement by this instrument. Here this instrument is given. That instrument which is showing beneath of this paragraph give two values. One is belong to voltage and the second is the current. They are being recorded under different load resistance. Then we will measure the current density and power density by taking an active area of 0.64 centimeter per square, which is already discussed at how we can measure the area of the pallet by using the pi or square formula. Then we plot a graph between the current density and power density and the voltage. Here the flow rate of hydrogen gas was kept constant, usually 80 to 100 milliliter per minute at 1 atmosphere pressure. This is the instrument which is being used for the measurement of fuel cell. Here you can see this pipeline, which is showing here, is uh, used for hydrogen supply. The second pipeline, which is coming from this side, you can see this pipeline. This pipeline is used for the air supply.